products expertise with the University of California. He works with the UC Center for Forestry out at the Richmond Field Station, the old Forest Products Lab. And John has done quite a lot of work with specialty forest products and some really unique ways to market wood products. And he's going to talk to us a bit about some of the utilization opportunities in oak woodlands. John?
Thank you, Rick, and greetings to all you well-connected people out there. My talk really is focused on utilization. Sometimes that's considered a bad word, but I like that word. Wood is a good raw material, and there are a lot of benefits to using it, so I'm going to focus on utilization. When we think about utilization, often we're thinking about the coniferous species, softwoods, that we know very well from construction lumber, from plywood, all the things that we build houses out of, paper. Kind of don't think so much about hardwoods, but hardwoods are also a very valuable timber, and you start looking around your house, you see a lot of things made out of hardwoods. Flooring, furniture, even a lot of paper is made from hardwoods. So we know it's a valuable natural resource, and the question then becomes, well, we have hardwoods in California, but I don't see much of a hardwood industry in California, so I'm wondering if there's a disconnect there. So that's what we're going to talk about for the next 20 minutes or so. When we look at California, we see hardwoods. We see a lot of hardwoods, actually. About a fourth of the total tree volume in the state is made up of hardwood species. And that table that you see in front of you on this first slide gives you kind of a sense of how that looks in California. Most of that is an oak species in either the forest land or the rangeland. But we also have large volumes of tan oak and madrone, and then a whole series of other hardwood species and that make up that component. And I throw in here the term exotic hardwoods, hardwoods that are not native to California, because we see a lot of those, not just in the rangelands with the eucalyptus that grow quite well in parts of California, but as we get closer to the urban environments, we see an awful lot of introduced hardwood trees that may have some potential value. So that's what we're going to look at. So we know we have a hardwood resource, and then we look around and see what kind of materials are made out of hardwoods, and we see that, well, California is a huge consumer of hardwoods. We have a lot of people, we have a lot of buildings that take a lot of furniture, we have a lot of hardwood floors, yada, yada, yada. So, there's a big market there. And in fact, about 100 million board feet of hardwood lumber come into California every year just to make products out of hardwoods. But we produce less than 5 million board feet of hardwood lumber in California. So there is a disconnect there. So the obvious question is there a market for California hardwoods? And that's what we're going to talk about for the next 10, 15 minutes. Before I get too far into this, though, I want to reference that the talk that was last week's webinar, for those of you who were dialed into that. A lot of attention was paid to, what is it we're really trying to do here? The hardwoods do have a value. We got to consider all of those values. We got the wildlife habitat, the structure and function of the ecosystem. You may have some conservation goals or biological diversity goals. Also that aesthetic and societal importance of those hardwood trees out there. And I add to the list wood products, because that is one of the considerations. All of this has to be thought about when you're looking at a management plan. You have to have good reasons for getting into any kind of a wood products production, but that's got to be the first place where you start. Think about what your goals really are. Now, we do know those hardwood trees, even though you may not think too much about them coming out of the landscape, they do come out of the landscape. Often they're hazard trees, trees that fall down in storms. There can be development goals for land where there are hardwood trees growing. Maybe even some reduction of fuel for wildfire, to lower that fuel risk. You may want to just like the idea of using some of the wood that's growing on your own land for some of your own use. That can be anything from maybe fence boards to barn timbers to fine furniture or hardwood floors. So there can be that incentive. And it even is possible to find that you may have a goal of supplying a hardwood manufacturing business, either in your local area or a startup of your own. So those are also some other considerations. So the question really becomes, if we're going to think about these hardwoods as a potential for products, what are we talking about? There's firewood, obviously, and that's the one most people think about when they're looking at our hardwoods. But there are also some very fine uses for these hardwoods. If we choose wisely, choose the right species, and know what the risks are and what the difficulties are in manufacturing, we can produce some very fine quality furniture as well. Where I like to start whenever I'm doing a talk like this is to think about the properties of wood. I mean, that's what I do. I study wood. So I look at things like cell structure. What do those cells look like? Because that defines a lot on how the wood not only looks but feels to the touch, and how it works with tools, how it behaves. We also look at that density. That's basically the weight of a material to a unit of volume. And density defines a lot of the properties in wood. So if I look at density, that gives me some idea of how well this particular tree might work in different products. Then I want to look at things like reaction wood. I'll talk a little bit about that because that becomes important when we're looking at some of the woodland or the rangeland trees. It's not quite a normal wood, just like I'm not quite a normal guy. You know, jokes don't work in webinars, do they? I didn't hear any laugh. Oh, thank you, Rick. And then look at how the grain orientation is in a piece of wood, because that defines a lot about how it looks. I like to call that character. You can get a lot of very interesting character in wood just depending on how you cut a piece of lumber out of a log or how the tree grew. We want to look at things like strength, stiffness, and hardness if we're thinking about using it for any kind of a structural use. And then we have to think about how is that wood going to behave in its environment. How does it take up moisture and leave moisture? How do the dimensions change when it's taking up moisture and losing moisture? And finally, I'm going to talk a little bit just about biodeterioration. Wood is a material that is attacked by decay fungi, by insects, so we have to think about that also when we're talking about utilization. If you're following along in that the textbook that was passed out for this webinar, Guidelines for Managing California's Hardwood Rangelands, most of the material I'm talking about is in pages 82 to 88, but I've updated that information quite a bit since I first wrote those pages. And there's a table in there, table 8.2 on page 85, that's similar to some of the tables I'm going to show you now. But one thing that's important when we start talking about the properties of these California hardwoods is really looking at strength properties, and they're highly correlated to density. So if you looked at this table that's up there right now, and look at this density column, that gives me a really good idea of how strength properties are going to relate. Because if you look at this, as we go up in density, from a low density of 0.46 up to, in the eucalyptus, up to almost almost 1, so 0.95 grams per cubic centimeter. As we go up in density, we also find that these properties like hardness are also increasing. If we look at strength, strength is also increasing. All of those mechanical properties or those strength and properties increase as the density goes up. So density is a really good indicator of how well this particular tree species is going to work for us. If we want something that's strong, you're looking at the oaks from the tan oak, the live oaks, even California black oak can be okay in some of these uses. But lower density species like poplar and the cottonwoods, very poor in strength properties, so we wouldn't want to be considering those. And then also you'll notice that when that density is increasing, look at the column on tangential shrinkage. We also see that that's generally increasing the higher values up at the higher density values. Shrinkage is really important. When we take moisture away from wood, it shrinks, and the more it shrinks, the more possibility we have for defects like warp to occur, where a board doesn't stay flat. It might cup on you, things like that. So we have to consider that. So density is a really important indicator. The other two columns that I have up here, texture and workability, these are really, texture is defining how this piece of wood looks to you. A fine texture is kind of nice and smooth and looks good. A coarse texture or a poor texture would have a rougher looking feel to it. And how good something works with tools. And again, as we go up in density, we see that there's a correlation there as well. The next slide I'm going to show you has to do, well, not this one, but there's a table coming up that'll take a little bit different look at density as well. So now we know we've got some species that we can work with, because you noticed that on that previous slide, most of those densities are in this category of about 0.5 or above, which give us pretty good working qualities from the California black oaks on up. So we have species we can work with. So let's look at some of the potential markets. The obvious one, commodity lumber. That's what you're buying when you go to Home Depot, or that's what your contractor's buying when he's building a house. It's a material that is in the commodity market. Very difficult to compete in that market. That's the one that all the big players are in. I don't recommend that for California hardwoods, but I do recommend the next category, the niche markets. Find something that really takes advantage of the unique character that we find in hardwoods, or there's some really interesting character or property that you can maximize. And even the fact that it's locally grown might be real important to a local market. So you start to develop some really niche market opportunities for hardwoods, and that's where I like to tell people to focus when they're thinking about hardwood utilization in California. We have had efforts to break into the commodity hardwood lumber market in California over the history of, at least the history I'm familiar with, the last 40 years. And with marginal success, so at least some short-term success, but nothing that has really had good staying power. So I think the niche market really has some potential for us. And then there are a whole host of low-value products that firewood I throw in that category, because there's a lot of labor associated with firewood. Even though when you buy firewood, you think, wow, this is really costing me a lot of money. It must be a high-value product. But when you consider the labor that goes into it, the profit margins aren't very large. And then things even such as mulch and compost are products of using that wood, but again, rather low quality. So we start looking at the tree. So we know we have markets. We know we have tree species that will work well to produce. They have the properties that we're looking at. So where is this disconnect? I mean, this is a really good natural resource, right? Wood is good. You've all heard that. Well, not all wood is good. And this is where we have to pay some attention, because as you all know where the devil resides, it's in those details. And we start looking a little closer at properties, and we start to see that, there's some real challenges here, and we better be careful in what we're doing here and knowing how we can address some of those challenges. And that's a large part of what I do, is focusing on those challenges and helping people work through some of those details. If we look at a nice nice stem of a tree that I showing here, you can see that we have these branches that form knots. We have a center of the tree that I call labeled the pith, the center part of the tree. This shaded portion over here, that is this darker shaded zone, the knot-free zone for high-quality lumber. That's where all the really high-quality wood comes from, what we call in the trade clear wood. Doesn't have any knots in it. It's what you will pay the most money for. And you can see it's not a very big chunk of that stem that's the high-quality wood, because in that center region, we have the knots that were formed earlier in the life of that tree. It's not until later years where this clear wood, knot-free wood, is developed by the tree. So we start looking at defect-free lumber or knot-free lumber. There's not very much of it in that tree. Other things to think about are these terms over here: juvenile wood, reaction wood. They're sort of similar. They're actually zones of wood in the tree that don't perform very well. Juvenile wood is near the center of the tree. It's the first 10 or 20 years of wood that the tree forms when it's a young tree, or as it's growing in height, the first 10 to 20 years of growth in that new height. That wood has lower property, lower density, lower strength. It behaves differently. It shrinks more. It's not very good wood. So we have a center core of that tree, the juvenile wood zone, of about 10 to 20 growth rings that aren't very good for us. Reaction wood is a similar thing, but it happens in leaning stems and in these branches that are formed. That wood behaves similarly to juvenile wood, different density, different properties, doesn't perform very well. So now we take this nice looking straight tree and we look at what we have when we're talking about our hardwoods in California. They're not very straight. They have a lot of branches. They basically don't have good form. And that's what presents a lot of problems in processing. All those branches and leaning stems have a lot of reaction wood in them. That is going to cause processing problems. All these branches that come out of the stem, these all have a lot of, create a lot of knots in the wood. There's a very small portion of this tree here on the right side that we might even have some clear wood in it, high value wood. So you can see it becomes a real struggle for somebody who's working with this to how do we get log out of here that we can keep good lumber out of. Well, it can be done. You just have to be aware of the difficulties. But all of these things that we do to improve the results add cost. So the costs of processing this material are quite high. Profit margins become lower, something you have to think about. And then when we get into working with this wood, we can create a lot of defects just when we dry it. Lumber looks great when you first cut it from a log. It has a lot of water in it. It's very fresh looking. It's nice and flat because you cut it flat. Once you start to dry that wood, it doesn't look so good anymore. It can create a lot of defects. And I've just listed some of the defects. Some of these are actually growth defects in the tree itself that can cause you problems when you're using it. But most of these I call stress-related defects. They happen when the lumber dries, when wood dries. And we can also get a lot of discoloration in the wood that also detracts from it. So there's a lot of things that can go wrong once we start to process this kind of material. And that's what I call these drying defects. They're created when we dry the lumber. A lot of it comes back to a very simple fact about wood. When we look at a round cross-section of wood, you can see lumber cut out of it in this cross-section. This board cupped when it dried. It was cut out nice and rectangular shape, but it cupped when it dried. And that happens really because the tangential shrinkage, or the shrinkage that's tangent to the growth rings, it's running, if you just drew a tangent line to the growth rings, shrinkage in that direction is twice as great as it is when the wood shrinks in the radial direction, or from a radius line from the pith to the bark along the radius. So shrinkage is twice as great in tangential direction. That means that wood doesn't want to stay flat unless it's cut out of what we call a quarter sawn board that has nice straight grain lines on the end. That stays flat when it dries because the tangential shrinkage is all in the thickness direction, and the radial is all in the radial shrinkage is all in the width direction. But when you have growth rings at an angle like this one up here, that board is going to cup because of this, what we call differential shrinkage. So we have problems when we dry it. And if you look at just these couple samples, it can be really quite serious defects. In this one, the pith zone, remember I said that wood around the pith, 10 to 20 growth rings, doesn't behave very well. When that piece dried, it just about destroyed itself. This is cell collapse that happens when you dry it. This started out as a nice looking rectangle, but now you can see it's really quite wavy on the surfaces. The cells collapsed when it dried. We can create stains in the, oh, my arrow's moving around. Oh, come back. We can look at stains in the tan oak lumber that are created when it dries, and in really serious cases, we get a lot of warp. This board here is a piece of red gum eucalyptus that it cupped, it twisted, it collapsed, it did about just everything. I love that board because it shows everything that can go wrong. So drying is really important. Now we come back to density again. Look, as density increases, drying difficulty increases. It becomes more difficult to dry, and we get a lot more defects as we get up in higher densities. And most of the woods we'd be looking at have a fair amount of difficulty in drying, from California black oak on up. Just want to mention one thing about blue oak. We really don't know very much about blue oak. It's never been much of an interest to anyone in utilization. A big part of that reason is we have a lot of blue oak, but it also has a center core of a rot and decay often in the bigger trees that makes it very difficult to process at all. So it's not really been used for anything higher value. But we have used California black oak. We have people using tan oak today. Some of the live oaks as well. Madrone is actually a very good species for fine quality furniture, interesting hardwood flooring. But it's also a very valuable wildlife species, and there isn't that much madrone out there, so we don't see a lot of that use. Eucalyptus has some real potential if you're careful in what you're working with. But they are very difficult to process. So really what we have to do is focus on how do we process this well to get the least amount of defects that we can. And these are just a couple simple recommendations that, I do a 2-day workshop on drying lumber, and I'm going to try and condense it into about 1 minute here. So you're not going to get much out of this, but there are things that we can do. We can stack the lumber correctly. We have put some weight on top of it, dry it very slowly when it's the initial drying. There's a critical period in drying lumber that goes from its fresh cut condition down to about 30% moisture content. That's where we set up the stage for all of those defects. Defects may not occur until it gets much drier than 30%, but the stresses start to develop above there. So I call that the critical period, or the critical stage of drying. That's where we have to be very careful. Once you learn that and you dry carefully in that stage, you can have much better results. And then we gradually increase drying in temperature. And there are recommendations for doing that. And if you're really serious about this, contact me and I can help work you through this whole thing. We also want to take some concern about sterilizing. What that means is killing any organisms that might be in there that could be of a concern for transporting them around, or decaying or insects in the wood. And we don't want to be careful not to overdry. So we can do a lot with wood. Here's an example of somebody who's working with tan oak logs with a portable sawmill. Has a center core of a defect zone that he's going to work around, stacks his lumber very well with nice straight lines of stickers, and produces a wonderful product, tan oak hardwood flooring. So it can be done, and he does it profitably. But coming back to that character, this is a piece of wood that actually has decay in it. It's called incipient decay. It's an early stage of decay. But it forms these very interesting discolorations and zone lines, has a very interesting appearance to it. So you can actually get more money for a defect if you market it carefully. So some things like that to consider. I did want to briefly mention something about insects and disease, because we don't really focus on that in the workbook, but you do have to be aware of them, because insects love wood. There are some beetles that will attack it, and they can do, particularly the dry wood beetles that are powder post beetles, can do a lot of damage in wood. And there are ways of identifying these insects, knowing what you're working with. But in reality, if you dry the wood, most of these beetles are not going to be a problem, except for these dry wood beetles. And if we control those by a high temperature in drying them, we can eliminate those. But if they reinfest, then you have to look at chemical treatment or fumigations. Also wanted to mention really briefly sudden oak death disease, because we do have an issue with that, and other tree diseases as well. This table, you can look at it later, but it shows results of a study I did on Phytophthora ramorum, which is the organism that affects that sudden oak death syndrome in oaks. tan oak and live oaks particularly. And just this study of trying to grow this organism out of fresh cut firewood and other ways of processing wood, really focus on these numbers over here. We got about 10% positive results out of firewood and sawdust from green nut dried wood. But once we dried the wood, the risk is very low. So these are things to think about. Is there a risk of spreading disease or insects around when you're moving wood, particularly with firewood? So understand what those are, and I can help you with more details on that if you're interested. So in summary, real quickly, what are your management goals? Are you looking at a profit, or you just want to reduce some costs, or do you have some other goals in mind? You understand what quality manufacturing practices are, how to get there, and then what the risks of moving disease or insect infested wood are, and really focus on lumber drying, because that's where a lot of people make their mistakes. And then when you get to marketing this, look for that local niche market and really emphasize the character of the wood. That's the end of my talk. Thank you.
Yeah, thanks, John.